In this lecture, we are going to solve an important problem of pair of straight line, that is from two-dimensional geometry. And the problem is a point moves so that the distance between the feet of the perpendicular from it on the straight line given by the equation ax square plus 2hxy plus by square, this is equal to 0, is a constant. This is given by 2D. Then that its locus is given by this relation. Okay. So here it is given that a point in xy plane moves in such a way. We draw a rough sketch of the given problem, and this is the x-axis and this is the y-axis and this is origin. Okay. We first draw the straight line given by the equation ax square plus 2hxy plus by square equal to 0, and we know that this represents two straight line or a pair of straight line passes through the origin. Let this is OA and this is OB. Okay, OA and OB, and let any point P, this is P, and let the coordinate of P is x dash y dash. We have to find the locus of the point, variable point P, that is the locus of the point x dash y dash. Okay. Now we have to draw two perpendicular from P to OA and P to OB. Let two perpendiculars are PA and this perpendicular is PB. Okay. These are perpendicular on the line OA and OB. Okay. So this is pi by 2 and also this is pi by 2. And this is P, and we add the 2 point OP dash. Okay, clearly here OP, sorry, this is not P dash, OP, this is equal to root under x dash square plus y dash square, because this is the distance of 2 points. And it is given that the distance between the feet of the perpendicular, here feet of the perpendicular are A and B. This is the feet of one perpendicular and this is the feet of another perpendicular. So we add AB. We add 2 feet of the perpendicular, and here it is given that AB, this is equal to 2D from the given condition, and this is a constant 2D. Okay. Now we use two important property of geometry, and two important properties are, we already write these two property. The first property is angle subtended by an arc of a circle at any point on the remaining part of the circle are equal. Okay, and in Bengali this property is said as একই বৃত্তাংশস্থ সকল কোণের মান সমান. Okay, and the second property, if sum of any opposite pair of angle of a quadrilateral is 180 degree, then it is called cyclic, or it may be said cyclic. And in Bengali বৃত্তস্থ চতুর্ভুজের বিপরীত কোণগুলি পরস্পর সম্পূরক, and these two are very important theorem of possibly of class 9 or class 10 standard. We all know these two property or these two theorem of geometry. This is very important two theorem of geometry, and we use these two theorem of these two property of geometry here. Okay. Now here we first say this is pi by 2 and this is also pi by 2. So these two angle, sum of these two angle must be pi by 2, and since angle PBO plus angle PAO, this is equal to pi by 2. So we say that sum of other two angles is also pi by 2 for the quadrilateral OAPB. That is angle AOB plus angle APB. This is also pi by 2. And clearly using the second property, we say that quadrilateral OAPB is cyclic. Okay, so for the cyclic quadrilateral we use the first property. Now we say first another one point. Let the angle between OA and OB, this is theta, and we know that the angle theta between two pair of straight line given by these two lines are given by tan theta. This is equal to 2 into root under h square minus AB by A plus B. And from here we write that sin theta by 2 into root under h square minus AB. This is equal to cos theta by A plus B, and this is root under sin square theta plus cos square theta by root under this square and this square. So we get the upper portion is 1 and the lower portion is 4 into h square minus AB plus A plus beta whole square and this root. So we write from this relation we get sin theta. This is equal to 2 into root under h square minus AB by, this is written as root under 4 h square, the first term, and this is A plus B whole square minus 4AB. So this is A minus B whole square. Okay, and this is an important property or important relation of this problem. Okay, we get the value of sin theta. Now using the first property, if we draw a rough circle like this, okay, since this is cyclic quadrilateral, so it inscribed in a circle. Let it be the circle in which the quadrilateral inscribed. Now by using the property 1, we say that this angle and this angle are equal. Why equal? Because these two angle lies on the arc OA. Okay, so we write angle OBA. This is equal to angle OPA. Now here we use a property of triangle is given by, for triangle we know that A by sin A, this is equal to B by sin B, and this is equal to C by sin C. This is very popular property of triangle, and now we use this property for the triangle OAB. Okay, now for the triangle OAB we know that AB, this is the side AB, and the opposite angle is AOB, that is sine of angle AOB, and this is given by OA, another side, and the angle is sine angle OBA, and we already proved here angle OBA, this is equal to angle OPA. So we write here this is equal to OA by sine angle OPA. We only use for this angle is equal to angle OPA. Okay, and we know that AB, which is given in our problem, AB is given by AB is given by, we write here, this is 2D, because it is given that the angle, this is given by a constant 2D, and we write here AB, this is equal to 2D. And sine, this is angle theta, because we already let this angle is theta, and we also find the value of sine theta here. Okay, so we write first this is theta, and this is given by OA by sine angle OPA. We write as here angle OPA. Okay, this is an important relation. Now use the same property of triangle for the triangle OPA. For the triangle OPA, we get OA by sine angle OPA. OA by sine angle OPA, because this is the side and this is the opposite angle. This is equal to OP. OP, this is the side and the opposite angle is this. OP and opposite angle is this is the whole angle, and this angle is pi by 2. So we write this is sine pi by 2. Okay, and this is OP. OP means we already find the value of OP. This is equal to root under x dash square plus y dash square. This is OP, and by sine pi by 2 means 1. Now putting the value of OA by sine OPA, this is equal to root under x dash square plus y dash square by 1 directly. Here we get the relation as 2D. This is equal to sine theta. This is sine theta, multiply here into root under x dash square plus y dash square. Okay. Now putting the value of sine theta, and this is given by 2 into root under h square minus AB by root under 4h square plus a minus b whole square into x dash square plus y dash square. And now squaring both sides, and by cross multiplication we write the result as 4 into root, after squaring root vanishes, h square minus ab into x dash square plus y dash square. This is equal to 4d square into 4h square plus a minus b whole square. Okay, and 4 cancel out. Now putting the value of x dash y dash by x and y, we get the locus of the point P. So the locus of P is given by we write here h square minus ab into x square plus y square. This is equal to d square into 4h square. This is not first bracket, this is second bracket, plus a minus b whole square. Okay, and clearly this is our required result. Very interesting problem, and this is the full concept of geometry. We use 3 concepts of geometry, 1, 2 and 3. Okay, thank you for watching.